angular velocity. It will measure linear velocity. Ruyong Wang showed that. Yet we consistently in experiment cannot measure either. And it's been done repeatedly, not just Michelson Morley, but on through 2004. And I think Ruyong Wang has done more experiments since then. I think the last I saw was one in like 2014 or 16, something like that. So I don't buy that Michelson Morley just disproved the ether. I have a hard time getting hold of that paper. All I can read is like something from a journal. I'm not even sure that it's available. I've requested several papers that you have to get the author's permission to even see them. So I've put in for them, but I don't know if I'll get them. But I disagree. We didn't disprove the ether with Michelson Morley. We showed that we could measure no angular velocity, and Einstein thought that was problem enough to come up with special relativity. Because I'll find the quote, but he said that it was something like unthinkable to have to admit that the Earth wasn't moving like that.
Yeah, that's a fact. One of the reasons why we had addressed some of those questions the way it's laid out, right? Because they'll say, "Oh, did Michelson Morley debunk the ether?" Of course it did, and then they'll say, "Well, is all you need to explain Michelson Morley was to just get rid of the ether?" And then they'll say, "Of course." When they say, "Well, okay, well, if that's the case, then why do they have to implement relativity if all they need to do was get rid of the ether?" So yeah, I don't. Can you see the questions, Ken?
Um, is somebody questioning something, or you just asking me in general?
It's these questions that we were going over with. Oh shit, I didn't even know you had DM me.
No, there's several people, prominent people, like Lorentz, who said at the time, briefly, everything occurs as though the Earth is at rest. Period.
Right.
Then you had Poincaré. I think Poincaré or Poincaré or Henri. He's French. Anyways, he's the one that said that lots of, it's paraphrasing, uh, lots of experiments have been done, and you know they all show uh, negative results. Uh, you know, all these experiments to measure the motion of the Earth are negative, and this was a problem to them at the time. And so for somebody to come along now and say, "Oh, all they did was disprove the ether," no, all of these physicists uh, took exception with those results because it did not lend credence to the heliocentric theory. There was a problem, and that had a lot to do with why Einstein was was accepted in the long run. There was resistance because it went against a lot. People, physicists went with the ether because it explained so much, and then we just dropped all of that and went with uh, Einstein's special uh, relativity because it explains why we couldn't measure angular velocity, why there was no angular velocity. That was the troubling part to the physicists at that time, and you can see it in their quotes. You can see how seriously they took the Michelson-Morley results. They were null on angular velocity. I mean, you can't get around that. Somebody has to explain why all these physicists then considered it a big problem. Even Einstein, who came up with special relativity, they're going to have to explain why all these physicists went to so much trouble to explain these results when all it did was disprove the ether. That doesn't make sense. It doesn't make any sense whatsoever.
A lot of contradicting philosophies, man. I agree. But this is why I feel like it was important to like talk about this, because it's like, bro, these guys really don't know it. I mean, even like it was shocking just to hear Franco say like he don't know the history of the physics like that for real. And I guess that's a little bit different when we talk about history, but and that it is honest. Say, hey, bro, I don't know about that. That's not like my specialty of how these things came to be. I just learned them. But that'd be our main point. It's like not even like the top physicists in the world like really pay attention to how these things came to be. It's like, okay, what did they say for us to learn? Okay, cool. I'm gonna store this for whenever I need it until I don't. Then I'm gonna forget, and I'm gonna fill my brain sensory up with other things that I need to know in particle physics. So,
Can
that.
can I speak?
Oh, there you go, Franco. Yeah, yeah, yeah.
So I was hearing Ken speak now. Again, as far as I know, they were not trying to measure angular velocities. Again, I repeat this. They were trying to measure the velocity of Earth with respect of the interferometer with respect to the ether. And yes, the result was null, and then the special relativity came up, and then special relativity happened to explain a lot of other things, not just Michelson law, a lot of other things. Without, if you allow me to say this, I was hearing someone say before that quantum physics is not compatible with relativity. It is compatible with special relativity. It is not compatible with general relativity in that we do not have a quantum description of gravity as yet, a viable one. But special relativity is totally compatible with quantum physics. Indeed, quantum field theory is also called relativistic quantum mechanics. It is all done and constructed in order to be Lorentz invariant and Lorentz covariant. You see all, if you look at the Lagrangian of the Standard Model, it's written in a Lorentz covariant way. It means that it has to be invariant for Lorentz transformations. They are assumed to be the transformations. There's no particle physics without special relativity.
Hey, man, you don't have special relativity everywhere. We can get into that in a second, but just real quick, I just went to just Google it. I was trying to find like specific papers on it, but interferometric measurement of angular motion, American Institute of Physics. Interferometric detection of angular velocity of moving objects. This is Institute of Electrical and Electronics Engineering. Is there anything that says interferometric measurement of angular motion, Harvard, 2013. ResearchGate.net. I don't know. You guys use ResearchGate? I feel like I thought you guys were like talking shit about ResearchGate.
I do.
Oh, okay.
I do. I use it.
Yeah, I use it too. I feel like I seen Franco and them talking about that. Franco, do y'all use ResearchGate, or do y'all not appeal to that?
Well, it depends what I'm searching for. I usually just use Google and then refine the search.
Okay. That was just wondering because I seen a pop up, but they also got something on interferometric angular velocity millimeter wave. Apparently they could detect fringe shifts or interference like 1/100th or 1/1000th of a proton width of interference, like something crazy like that. But anyway, I just read a couple headlines. It is just headlines. I didn't look at I was trying to find specific excerpts for you, but it does say that interferometry detects angular motion. So, like, are we on the same page about that now?
Yeah, I think it can. Yeah.
Okay. So again, we kind of got lost in the weeds, trying to highlight some of these contradictions here. But let me see if I could just double back.
Oh, if I may comment on one thing you said about because you said about the contradictions and the fact that you cannot have it a curved path in one view and a linear path in another view. There's two things I want to comment on this. One is, it's not true that from the general relativity point of view, the curved path of the Earth is a linear path. It's not. In the frame of the Earth is stationary by definition, right? The frame of something means that that frame of reference in which the object is still. So, meaning that from the point of view of the Earth is moving in a linear path does not mean anything. From the point of view of the Earth is stationary. From my point of view, I am stationary, even if I'm on a train, right? On a moving train. In my point of view, I'm still. So the fact is that from the point of view of an observer which is free falling, then the laws of physics do not have to take into account the fact that the frame is accelerating, meaning that a free falling system, a free falling frame, is inertial, which is to say that it's got the same physics as a frame which is moving linearly in the absence of forces. But in the presence of forces, it doesn't make any sense to say that it's moving linearly. Like it's in the frame of the Earth is stationary. In the frame of the Sun, the Earth is revolving around the Sun. Then the second thing is, it's not a contradiction to say that two things appear differently in two systems, because it's like saying that it's not logical that if I am standing, I see, I don't know, I see the trees going up, and if I'm lying, I see them in a perpendicular direction with respect to myself. They contradict, and they cannot be true at the same time. No, it's 2 points of view, right? It's 2 different points of view in different frames. So they're describing the same thing viewed from different using different coordinates and things like that, different point of views. The same thing can be viewed by different observers and at different angles and so on. So it's no contradiction, and it's not a logic contradiction.
You say that, Franco, but come on, man. Like, look. So basically, if what Franco is saying is, like, let's say if I was on a I don't know, a merry-go-round, right? And I walk from one side of the merry-go-round to the other, like it was a straight path, you know, but as soon as that merry-go-round starts turning, like, am I still walking in a straight path? Now, on the merry-go-round, I am walking in a straight line, but as the merry-go-round turns, me as an object, am I going in a straight line, or am I going in a curved path?
I'm not sure I understood the question, but if I'm in a merry-go-round and I'm sitting on a seat in the merry-go-round, so I'm stationary with respect to the merry-go-round, that from my point of view, I am stationary. From the point of view of the people who are outside and watching me circle, I'm describing a circular path and circular motion. If I move with respect to if I get up from the seat on the merry-go-round and move, then I will follow some certain path, depends how I move. And seen from the other observers, I will take a different path. But it's not. This is not a contradiction. This is the same thing seen by 2 different observers. It's not the same thing as what happens with free falling, because if I'm on a merry-go-round, I'm not free falling. The example would be if I just jump out of the balcony at the 50th floor and fall down in the absence of neglecting the resistance of air, then while I'm falling down, then in my frame of reference, then it would be as if I'm not experiencing any force at all. So, for instance, I wouldn't feel any weight. I would be able to, if I was in a closed cabin, in a closed elevator, precipitating and falling down, things would float like on a space station. What happens in so-called zero-G flights, right? They are free falling for a certain amount of time, and then things start to float because they don't experience. It's like they are in.
But Frank, what does that got to do with like direction, bro? Like, I'm trying to figure out, what does that have to do with direction? Because the only thing I hear is that you're explaining the free falling, which is really have to do with linear motion. And the reason why they're applying linear motion is because interferometric instruments back then weren't designed to detect the linear motion. So you're focused on the free fall and explaining how we don't feel anything in free fall. And it's like, that has literally nothing to do with what we're talking about. Damn, bro. I be trying to let him finish, y'all. I be trying to let him finish. I be trying to. Bro. Ken, I hope you heard what he was saying. You probably wanted to say something to Franco as well. But
yeah, no,
I'm sure he can still hear you, so you could talk. He'll probably respond when he comes back up.
The linear velocity is that was. I can understand why he used it, because that was the answer to Michelson-Morley. I'm still hung up on all they did was disprove the ether. So what I've done here is I've got some quotes from people at the time speaking about what these results meant to them. And so I already quoted Henri Poincaré. A great deal of research has been carried out concerning the influence of the Earth's movement. The results were always negative. Again, Henri Poincaré, we do not have and cannot have any means of discovering whether or not we are carried along in a uniform motion of translation. Wolfgang Pauli, the failure of the many attempts to measure terrestrially any effects of the Earth's motion. Arthur Eddington, there was just one alternative. The Earth's true velocity through space might happen to have been nil. Henrik Lorentz, briefly, everything occurs as if the Earth were at rest. Albert Einstein, to the question whether or not the motion of the Earth in space can be made perceptible in terrestrial experiments, we have already remarked that all attempts of this nature led to a negative result. Before the theory of relativity was put forward, it was difficult to become reconciled to this negative result. Now, these are all the people at the time that were looking at Michelson-Morley. They were not worried about the ether. Now, Einstein did away with the ether in his theory. I'm assuming because it made it work better. But even later on, he said that he thinks it might have been a mistake to get rid of the ether. And I can't be exactly sure why he thought that. I've only heard someone quote him on it. And so I would have to find where exactly that was said and get a little more on that. But again, you can go with Albert Michelson, the man who performed the experiment. This conclusion directly contradicts the explanation, which presupposes that the Earth moved. right? Bernard Jaffe. The data are almost unbelievable. There was only one other possible conclusion to draw, that the Earth was at rest. All of these people had to be, these physicists, they had to be absolutely fooled, according to people today that are running around saying they only disproved the ether. That's what it was about. That's what the experiment was about. Lincoln Barnett, nor has any physical experiment ever proved that the Earth actually is in motion. Julian Barber, thus, even now, 3.5 centuries after Galileo, it is still remarkably difficult to say categorically whether the Earth moves. You know, I just do not buy. Oh, it just disproved the ether. No, not according to all these physicists. There's no way. You can't come in and say, oh, it just disproved the ether, because it absolutely did not to the people at the time. Like I said before, it troubled Einstein enough that he developed the special theory of relativity. And, you know, to explain away the negative results. And it became accepted. And, you know, and that's, you know, that's fine. If you want to take special relativity and say, well, yeah, you know, they couldn't measure the linear motion that it's going in around the geodesics. Fine. But don't say all they did was disprove the ether, because that is not what the physicists at the time thought. That is not what was foremost in their minds. Hey, we disproved the ether. Okay. No, they were all worried about the negative results that showed the Earth was not in motion. That's what that experiment showed. And that's what subsequent experiments have shown, even as interferometry got better and better. Miller even had wound up with Michelson's original interferometer, I guess when he was working with Morley. He eventually wound up with it, but he